All the little our intestine fluids.
Mhm.
I didn't realize until question 7 that in order to actually go over it effectively with you, that would entail me not submitting all the questions.
Yeah, as soon as you submit it, it's done.
So I'm done with the test.
Cool.
So, and then I go back and I look at all my mistakes that I found.
Oh, so it gives you a report.
No,
Oh,
I just in my work, I'm like, oh,
I see you.
I divided by 60 instead of 3,600 going from hours to seconds.
Seconds.
Yeah, so a lot of stupid mistakes.
All right, so we had G of S and H of S, and we had just completed the square, all right, because both our denominators have that S squared minus S plus 5. So we can rewrite G of S now, all right, so back to what we were actually looking for. With our adjusted, our square completed. And we had already identified, it looks like 19 and 20, all right, from the Laplace transform table. Once we're here, okay, so now I substituted in our clean square. What do we need to do, Josh? What should we do to get it closer?
Add 0.
Nope, not yet. To get it closer to our table.
You gotta look at the denominator, make sure the denominators match.
Yeah, no, this looks like 19 or 20, but so now it's time to mess with the numerator.
Let's make sure it matches
Yes,
form.
correct.
So it has to be S minus A.
Correct. So what should we do?
Subtract a half from both sides, from top and bottom.
Yes, but there's something we should do before that.
Oh, you're killing me. I don't know.
Break this into 2 fractions.
Okay.
You're absolutely correct. I'm going to have to do S minus half, 100%, right, which is the adding 0. But first thing, this 11, if in order to get this down to negative half, so I guess we could figure this out, right? Factor 6, so it'd be 11, 6, and then somehow to make that negative half, right?
Add a 6.
Well, I'd have to add the 0. It's still like negative 6 plus, it would be plus 11, 6. Minus 11, 6 plus half minus. So actually, this doesn't help us out because that's the only way to make that work. All right, but I was just thinking how complicated we can make adding the 0. But yes, the best thing, all right. While I'm at it, let's pull that down there. Because this is literally all just algebra. So now I have that. Then I have minus. Actually, let's write this as plus negative 11 because we're going to have a mess here. That alone is actually a pretty big step. Now you're absolutely correct, Josh. This is where we get to add 0. But I don't want to add 0 until I have this like manageably separated, right? Because yeah, now I have a 19 and I have a 20. So now plus half minus a half, adding 0. All right, so I have a negative 11. All right, the negative half, so the plus 1/2, all right, with, all right, that coefficient in front. because that has to come over, right? Since I pulled that down, that needs to come over as well. And then I should just have something relatively simple over here. This now should match exactly 19 or 20, 20. So this is exactly number 20. Right, with A. All right, what is A here?
1/2.
1/2. And what is B?
Root 19/2.
Then this guy we need to mess with just a little bit. Let's see, what are we at? 3. Oh, this actually is easy. 3, -8. In order to fix the second guy, what do I need to do?
Multiply by 1, so 1/2/2. No,
One more time.
wait. You want to multiply by 1, right?
Yes, multiply by 1.
A root 19/2.
All right, that one moves in, so this actually needs to go out and it's gonna leave change flip, right? Actually, let's write this just to be super clear. That's actually -8 all over 1 over 1 over 1, just so. Because this actually comes over and then leave it, change and flip it as -16 over root 19s, right? That's the big, that's the toughest part, I would say. And so then this guy is number 19, same thing with A equals 1/2 and B equals root 19 all over 2. Lastly, and definitely not least, technically we didn't point this guy out. This is number
1.
1, right? Our favorite. All right. Okay, so finally to G of T. Okay, don't forget we have this 1/5, right? That's been parking out there. 1/5 4 plus 6. Okay, and then number 20 e to the 1/2 t cosine of root 19 halves t. Minus 16 all over root 19 e to the 1/2 t sine root 19 all over 2 t. Okay, we got that guy. Now we get to do h of s. So that was just g of s, right? Recall our very first step, right, that we did last time was pull this into G and into an H. All right, we did the partial fractions on individual. All right, but good news, this one will be very, very similar as well. All right, H of S. And same thing. Once again, just practicing. Josh, what do we need to do?
Separate the numerator.
It basically starts the same every time. Gonna separate. And actually, let's fix both of these. Oh, no, I gotta bring that over one more time. Hold on. So minus half plus half. Okay, so that's 3, and that's the plus half comes over, but it's minus, so it's actually 2.5, which means makes this 5 halves. And then same thing, root 19 over 2. Rewrite that one more time, just for completion. Nineteen, that goes away, so it actually becomes 5 over root 19. And clearly, right, we have a 19 and 20 perfect forms now. And then that guy's a number 2. So h of t equals. Okay, now here's the really good part. Remember what we were doing. Okay, so we got H, I found a G of T, I found a H of T. Feels like I should just be able to put them together, right? And got my answer.
You have to multiply by t because you have the same multipliers.
No multiplying by T. What is this again?
That one heavy side.
Heavy side function, which means that when we put this together, all right, so H of S, which is now H of T,
U2T.
U2T, which means everything in H of T needs to become
2 minus t or
T minus
2.
minus 2.
So yes, it all needs to be adjusted because that is a heavy side function. Let's write that out. Jeez. All right, so was it F? I forgot. We'll call it F. F of t equals G of t plus U of 2t H of t minus 2. Now we can put the whole thing together. So G of t is exactly what we had written above. And so again, wherever there was a t, I'm gonna replace that, right? In my function here, all these t's need to be replaced with t minus 2's. Yeah, it's so pretty. All right, one more example again, one last time, make sure we practice. All right, solve the following IVP as presented. Notice it doesn't say what technique to use. Why do we know we need to use Laplace transforms?
Is the chapter recovering?
What else?
It has the heavy side in it.
Has the heavy side. All right. That's the heavy side function. And so when I'm going to do a Laplace transform of this guy, just like we just input it back in, if it's next to a heavy side, what form does this cosine 2t minus 12 need to be? What do I need to do here?
T minus 6.
And factor out t minus 6, aka factoring out a 2 gives me a t minus 6. And so I have the right form. Right? No need to add zeros. All right, so Laplace transform of derivatives, right? Number 35, 36, 37 on the table. Cosine of 2t, what does that guy look like?
S over S squared plus A squared.
Oh, yeah, you said a squared. Yes, but in this case, yeah, I was like, wait, what? You're correct. All right, and then, all right, always want to make sure that we're messing with this guy. Okay, so this becomes plus e to the, how does the heavy side transform? I already forgot.
Negative 6S.
Okay, and then, all right, remember identifying, here's my function, all right, let's call this k of t, and let's call this k of t minus 6, which means k of t is actually cosine of 2t, which makes that exactly the one we just had. The important part, right, about heavy side functions is that it's really just the beginning and the end. Remember, in the transform part, I only know this is a heavy side because it's literally next to an e. But you don't have to worry about the t minus 6's. You immediately convert them and then convert them at the end. All right, so you don't actually deal with the fact that there's an adjustment to the functional value, all right, within. All right, we got enough going on with with partial fractions and adding zeros and multiplying by ones, right, in the process of doing Laplace transforms, right, without having to worry about the adjustment of the Heaviside function. All right, then, okay, so this is what I got, all right? So again, we're refreshing on the whole process. This is the big part. What do I do now? All right, I did the transformation.
Substitute
Substitute what?
initial values.
Yeah, this is the strength of Heaviside functions. We find the actual solution, okay, by, right, input, initial conditions. No solving for constants and coefficients. We get the full, right, tomato at the end. All right, so we have that. Divide s squared minus s, because we're solving this to get equal to f of s. So we're going to end up, going to get a little worse before it gets better here. And then again, just some things to note. Does anything jump out at you? Try and make our lives easier before, because what's our basic next step? Where are we headed towards?
Partial fractions.
Partial fractions. So is there anything that kind of jumps out that maybe might make our lives easier before we go rushing into partial fractions?
You could factor the s squared minus s, pull out an s.
Pull out an S.
Well, for the left one at least. No, because of the s on top.
For this one you mean?
Yeah.
Yes. For that one, yes, I do see cover up in my future. I was like, yes, I do not see cover up in my future here.
Not that one.
I was like, but you're absolutely correct. Factoring an S, all right, I need to fix that mess right there. S factors there, that actually leaves me with 1 over S minus 1 times S squared plus 4 plus 1 over and actually, I see even more good news. All right. Is there anything else we see over here? Negative 4s plus 4.
You can pull 4 out.
Yeah. Let's do that real quick. Let's pull a 4 out. think I should just pull a 4 out?
A -4.
Look, if I pull a -4, what does that become?
Makes the tops match, or it makes the numerator match the denominator.
And then what do you see? Oh, look at this. I don't see cover up in my future. You're absolutely correct. I mean, I was seeing the same thing, and I was like, wait a second. I was like, oh look, that is number 1, right? Our favorite. So again, wherever you can simplify, which actually means this guy. So that's a piece of cake. These are the same. So let's call that G of S plus G of S
Times.
e to the -6s, which means I see one partial fraction. Occasionally the gods reward us. Okay.
Rare.
It's rare. I was like, we have to earn it by doing the really, really tough ones. And then it's like, oh, look, that's a piece of cake. So, all right, skipping the partial fraction details. My coefficients, which leaves us with this guy. Good news, the first one, piece of cake, right? That's number 2. Solve that guy down. What about the second piece? Break it apart. Because what do I see? What's it going to be? What numbers am I in on the Laplace table?
19 through 20, or 19 through 22.
Okay, hold on. Don't say anything. I was like, does it look like 19 and 20? I was like, I know we've done quite a few of those because I want to make sure you guys can do the hard ones. Does this
Not
look
really.
that tough?
No.
Does it look a little easier? Maybe like
maybe 8.
it looks like 7 and 8. Now again, and that's why we always say 7, 8, 19, 20, like whatever, because I think I'm gonna have 7 and 8, right? But it looks like that row. Yeah. I was like, oh look, once again, the gods rewarded us again. This is like a piece of cake in comparison to what we have been doing, right? So I was like, yes. 100% agree. We see 15, 16 through like 22 a ton. Those horrible messes a lot. But occasionally we have something nice. Okay, so let's see. Because when I separate this, I get minus s squared plus 4 minus 1 all over s squared plus 4.
This one will be easy.
Go ahead.
So this one will be pretty easy.
I know. This guy, what do I need to do? Add 0, right? And no, that's done. What do I need to do on this one?
5/2/2.
2/2. Oh, it's not even a fraction. Script fraction? Like, how dissatisfied. That gives us then G of T equals 1/5. All right, so yeah, so this guy is number 2, clearly number 8, and then I got a number 7. All right, piece of cake all the way around. Okay. All right, so just FYI, so here's where we were with our f of s. So this guy is that's number 1, right? It's literally just gonna be number 4. And number 1, I mean -4. So -4 plus G of T plus, it's the plus G of T, right? Plus G of T plus G of T minus 6. U of 6T. And again, I always just write this out just so we can keep track, right, of everything's going on. We got H's in it. So that way I know, okay, I'm gonna have this guy by itself and then this guy adjusted. Beautiful. Yeah, boy, that didn't take very long to write either. Again, it's nice to end on an easy one. All right. Okay. One last little note. All right. So this one you guys have all the way written out. If I wanted to solve, all right, this IVP where G of T is this function, we can turn this into, right? We're good at making these as heavy sides now, right? You start with the 2, then the next one. Okay, right? So it becomes 2, then subtract, right? T minus 2, U of 6. Right? We start at U of 6. Then 4 minus T, U of 10. Remember, in order to turn a piecewise into heavy side, it's literally just subtract the previous term. Now, the mess in this comes that, oh, look, I have U of 6, but I actually need a T minus 6 here, right? Which is why I did it. So adding zeros, Joey's favorite part. So we have to do some add zeros. Same thing on this guy, add some zeros, and G of T actually becomes this to be the proper form in order to do the Laplace transform of the D. Go through initial conditions, solve, partial fraction, all right? Undo it, all right? And notice we ended up with, I had a K, an H, and a G, so lots of partial fractions, okay? Definitely something we could do, all right? Basically, we did that over the course of several days. We did this equivalent function. My point is this, without Laplace transforms, notice what we're gonna have to do. In order to solve this without Laplace transforms, we would need to solve that function equal to 2, the first piece, on the interval from 0 to 6, okay? So that same function on an interval. That would then give us this piece of the solution, which actually the G and the K from above. Then from 6 to 10, I'd have to solve it equal to T. Notice that in our piecewise, right? In our piecewise function, I have 2T and 4. So I'm solving basically, in order to do this manually without Laplace transforms, I have to do this function equal to this. Then I do this function equal to this. Then I do this function equal to this. So you have 3 Laplace transforms on their own based on particular intervals to solve. And notice that as we're going through it, since I'm doing it on a particular interval, notice my initial conditions become more hassle too. The initial conditions are based on what the previous function ended at 6. Wherever it ended, then I have to find that within the function of the solution, and then that becomes new initial conditions on the next piece of the interval. I solve that down, and oh look, it actually does y2, the solution to that mess, when you solve that, right? Because this, in order to solve this, what method would we use? Right, ignoring this.
I guess.
Yeah, undetermined coefficients. That is undetermined coefficients method. Okay. You would get it down, and oh look, then we do it a third time with some work. And notice again 10, because I have to pick up where the previous one left off, find the initial conditions. This actually, with some algebra, I can make this solution equal to Laplace transform solution. Possible, yes. Total nightmare, absolutely. So no matter how bad you think occasionally partial fractions is, multiplying by 1 and adding the zeros can be, it is nothing in compared to doing undetermined coefficients on particular intervals, and each time you have to do the derivatives, and again, after that, then you plug in the initial conditions again, because we're still just getting general solutions, usually without constants solved. So no matter your complaints on Laplace transforms, this actually is the cleanest approach. All right.
Doing this for my project that we were talking about was a pain in the ass.
Oh, finding the previous.
Oh, because you got to keep on replugging stuff
Yes,
in from each step.
Adjusted initial conditions, absolutely.
It's miserable.
Yeah.
It took me days to figure out how to code that.
See, and that's why Laplace transforms, they're just so clean, elegant. I was like, and partial fractions, it's all adding 0, multiplying by 1, and partial fractions are technically all algebra terms. I know that you may have not learned partial fractions until Cup 2, but it's an algebra concept, right? You just don't really
Use it.
like, if you had a really good algebra teacher, you might have learned partial fractions. But like,
Not until college, man.
usually only if you were in like algebra.
Yeah, that tracks.
But it's an algebra concept. I was like, there's no calculus in partial fractions, right? Okay. All right. And that's basically my point, that Laplace transforms very, very clean. We have now seen start to end of doing those. Got a couple of wonderful home fun questions to take a look at.